Welcome to this video where I would like to show you how to simulate a very simple control function written in C. For this purpose, I have implemented a function that reads a joystick input and controls the boom motion of such an excavator. For this implementation, I have assumed the following constraints. The joystick input will give us a voltage in range 0.5 to 4.5 volts, which we will measure in millivolts. And the control will happen with two coils controlling the hydraulic valve. One of the coils will control the direction up, the other will control the direction down. And for control of this coil, we will have current signals restricted between 300 and 700 milliamps. The implementation of the function is really simple. It uses two helper functions to scale the joystick input in minus 100 to 100%, and another function to scale the output in range 300 to 700 milliamps. The control itself is even more simple. It gets the sign of the scaled input, and based on it, it controls either direction up or direction down. Okay, let's go ahead and create our simulation. So place it in the main folder and call it boom control simulation. And I will implement it in C. Before I start here, I just want to mention that I have already downloaded the CppModel libraries, and those are for MSys2 UCRT64 environment. If you have another environment, go and check on the CppModel website if it is supported. So the main include file we'll need for this project is called CModel. And of course, we need to include our boom control function. I would like to create executable of this file. So I will start with implementing the main function. Within this function, I will create the simulation, and that is type CModel simulation underscore TS. And creation of the simulation happens with the function CppModel create. In here, I need to provide three parameters. The first one is the simulation name, which will be used to identify the simulation in CppModel workspace. Let's call it simulate boom. The second parameter is the total execution time in milliseconds. I will set 10 seconds. And the third parameter is the size of each step in milliseconds again. I will give 10 milliseconds, as it is a very common task time for the controllers. Now, since the simulation is created, we need to provide a function which will be called every step time. In other words, every 10 milliseconds for this simulation. That function needs to be of type void. I will call it turn cyclic. And it needs to have two parameters. The first parameter is a pointer to the simulation context. The second parameter is the actual time when this method is called from the CPP model environment. Within this method, we can call our bomb control function. And in order to make it work, we need to provide the necessary parameters, which were joystick input and a structure containing the output values. Let's simulate the joystick input. And I will just make it change its value from its minimum to its maximum for the whole time of the simulation, for which I will use the cycle time and the whole simulation time, which we have in our context parameter. Okay, with this, we expect that it will start from 500 and it will go all the way up to 4,500. Next, I want to create the output context, and that is of hydraulic valve output, TS type. And now when I have the necessary parameters, I will just provide them to control function. Okay, let's now present these values, both the input and the outputs. To present an input in CppModel, we can use the method CppModel override input. And I will use override input of type int32. I will provide the simulation context, a character string that holds the input name to be shown in the simulation result, and the actual value of the input. For the outputs, we can use function called CPModel set output. And in this case, I will use unsigned int32. The same here, provide context, output name, and output value. Okay, so our task is defined. Let's go and instruct CppModel to call it every cycle time. Function for this is CppModel set run step function. Here again, we need to provide a context, in this case sim, and the function name. There is one last thing we need to instruct CppModel, and that is to actually run the simulation. And give it the simulation. And for now, this main function will only return 0. Okay, with this, the implementation of our simulation is ready. We can now go ahead and compile it and run it. I will use the integrated terminal in Visual Studio Code and write the commands directly there. The first thing I will compile is the boom control. The second is the boom control simulation. And since that requires both the boom control function and the CppModel libraries, I need to provide it with the proper paths to the include locations. There's one more thing I would like to provide to this compilation, and that is a flag instructing underlying library, which is CPP HTTP lib, to use a secure connection with the server, and that is CPP HTTP lib open SSL support. Okay, now that we have both our files compiled, let's go ahead and create the executable. This line will require paths to the library folders and the necessary libraries, and those are the following. Now that we have our executable, we can just go ahead and run it. Since we have never logged in our CppModel workspace, it gives us a link where we can do that. And I will just open it and log in. I have already provided my credentials previously, so now it recognizes that I'm logged in. I can just go inside, and in my simulations, I can search for our new simulation, which is called Simulate Boom. In here, you can observe a simulation graph. In this case, is one input and two outputs, as we specified in the code. We can select a specific specific variable, I'm sorry, uh, or several of them, and we can zoom and move the graph around. You can see when the simulation was executed for the last time, what is the simulation duration in seconds, and what is the step size in milliseconds. And with this, I will conclude today's video. You can find the source code for this simulation in the description. Please feel free to post a comment and let me know what you think about CProgramming and this workflow. Thank you for watching and see you again in the next video.